From galaxies that are 13 billion years old to the changing color of Jupiter's great spot, we take a look at 15 objects in space that we can't explain. Number 15. The Moon's mysterious magnetic field. The Moon has remained magnetically inert for eons, but new research confirms that this was not always the case. Over 4 billion years ago, an inner molten moon core whirled against a lunar mantle, much like Earth's own dynamo, and a potent magnetic shield extended from the Moon. Surprisingly, our scrawny little moon was actually able to generate a mightier field than ours. No one knows why such a puny body displayed such potent magnetic activity, with current answers running the gamut from we don't know to magic. Number 14. The asteroid with rings. All our gas giants are encircled by rings, though most of these are tenuous wisps of debris quite unlike Saturn's massive sets of bling. And now, for the first time and quite unexpectedly, astronomers have found rings around a much smaller body. Meet Chariklo, an asteroid measuring only 250 kilometers across, yet boasting its own ring system. Chariklo, though the largest object in its cosmic vicinity, looked like an unremarkable chunk of space rock. It turned out that Chariklo sports not only one, but two cosmetic necklaces. Containing a good amount of frozen water, the larger of the rings hugging the asteroid is 7 kilometers wide, while the smaller is about half that size. Number 13. The six-tailed asteroid. Hubble has revealed yet another incredible curiosity, an asteroid that thinks it's a comet. While the latter bodies are easily recognized by their bright, streaming tails, asteroids do not usually have such a feature since they possess little ice and are made mostly of heavier elements and rock. So, spotting an asteroid with not one, but 6 tails was an incredible surprise. It was a unique find with its 6 spouting jets, as all other pieces of cosmic debris are quite content with considerably fewer. It blasts material indiscriminately into space, like a cosmic lawn sprinkler. Number 12. The color of Jupiter's red storm. You've probably seen amazing pictures of this massive red hurricane that's been whirling across Jupiter's southern hemisphere for at least 400 years. We know that it's a hurricane-like phenomenon, that you could fit 3 Earths inside it, and that it's cooler and higher than nearby clouds. Over centuries of observation, we've also discovered that it changes color, moving between a pale pink and a bright red. It's also shrinking. Unfortunately, we simply don't know the answers yet. Number 11. Hot Jupiter messes. Hot Jupiters, or massive gas giants in tight orbit around their stars, are one of the first types of exoplanets that astronomers began discovering in large numbers in our galaxy. What's puzzling about these broiling behemoths is how close they are to their suns. The substances you usually find in a Jupiter-like planet are found in the outer reaches of a solar system. So how did these hot Jupiters even form at all? At first, scientists believed that they migrated slowly toward their present positions from further away, spiraling towards their suns as their solar systems formed. Number 10. Galaxies 13 billion years old. The early universe was an approximation of hell, a roiling, opaquely dense stew of electrons and protons. Almost 500 million years passed before the baby universe cooled down enough to allow the formation of neutrons. Shortly thereafter, the universal landscape settled further so that stars and galaxies could come into being. A recent ultra-deep survey by the Subaru telescope, located in Hawaii and run by the National Astronomical Observatory of Japan, revealed 7 of the earliest galaxies ever. Over 13 billion light-years distant, they appeared as unimaginably faint pinpricks of light. Number 9. The incredible iciness of Saturn's rings. The ultra-thin, icy rings of Saturn are another familiar part of our solar system that are just as mysterious as Jupiter's red spot. We know what they're made of, and we understand some of the tidal forces that cause them to change shape. We're also pretty sure that they formed 4.4 billion years ago, right around the time when most planets in the solar system were coalescing. But we still aren't sure of how they formed, why they're made up almost entirely of ice, and why they're able to maintain such a perfectly flat shape as they whirl around the planet with its many moons. Number 8. Gamma ray bursts. Gamma-ray bursts are often called the brightest electromagnetic events in the universe. They release more energy in a few seconds than a typical star will during its entire lifetime. And we've only ever seen them in distant galaxies. At most, they last for a few minutes. UC Berkeley astrophysicist Martin Cirque said via email, "They have been known for 40 years, but their cause is still unknown. Some have been correlated with very distant galaxies, but most correlate with nothing." Number 7. The shape of dark matter. Dark matter is a hypothetical form of matter that appears to exert a gravitational pull on visible matter, but which doesn't interact with other kinds of matter in any other observable way. We know dark matter exists because the behavior of visible matter in galaxies makes no sense unless there is a lot more matter out there pushing things around and creating gravitational lenses. We've even got some pretty good ideas about the structure of dark matter. Based on Hubble telescope discoveries, we now believe it's likely that dark matter has a webby, filamentous structure, and that galaxies tend to cluster around its strands and nodes. Number 6. Cataclysmic variables. We've seen many kinds of stars in our galaxy, from red dwarfs to red giants. But some stars are particularly strange, especially when they come in pairs. Such is the case with a class of binary star called a cataclysmic variable. These are white dwarfs that are in an extremely close orbit around their companions. So close, in fact, that they are stripping the other star of all its gas. The particularly odd thing about these objects is that white dwarfs are the cores of red giants, and the companion stars orbit so close that they must have once been deep inside the red giant. Number 5. HD 106906b, the distant monster. This supermonster is 11 times more massive than Jupiter, and its gaping orbit highlights all sorts of flaws in our tenuous understanding of planetary formation. HD's distance from its parent star is an absolutely mind-boggling 650 astronomical units, or AU. The incredibly lonely Neptune, our most distant planet, lumbers around the Sun at a distance of 30 AU. This is already an amazing range, but HD is so far separated from its parent that Neptune and the Sun are comparatively within hugging distance. This huge discrepancy is responsible for the addition of many asterisks above our planetary formation theories, as astronomers scramble to explain HD's distance in spite of its vast orbit and heft. Number 4. Uranus is stormy. Astronomers have been caught completely off guard by Uranus. The second farthest member of our solar family is typically frigidly calm. But for some odd reason, the planet is currently awash in raging storms. Dazzling Uranian tempests were expected back in 2007, during its equinox as the planet completed half of its 82-year orbit, and the full solar fury was unleashed directly upon the equator. Yet the stormy weather was supposed to be a bait as Uranus continued its journey around the Sun. It hasn't. Number 3. UV underproduction. We pride ourselves on ascertaining the many universal balances that seem to occur throughout the cosmos. One such correlation has been observed between ultraviolet light and hydrogen, as the two have been found to coexist in well-defined proportions. Two accepted processes produce UV radiation, unruly young stars and massive black holes. But more UV radiation exists than could have been produced by the two. Astronomers can't explain the superfluous UV production and are forced to admit that at least one thing we thought we knew about the present-day universe isn't true. That's quite disheartening, considering that UV hydrogen balance was believed to be very well understood. As in many times in the past, astronomers are forced back to the drawing board. Number 2. KIC 2856960, the Triple Star System. The Kepler Space Observatory is usually busy hunting down new planets, but it spent 4 years of its life tracking 3 gravitationally bound stars, collectively known as KIC 2856960. KIC was just a run-of-the-mill triplet, 2 little dwarf stars orbited by a third stellar body going stag. Nothing weird so far, just 3 stars. Kepler saw 4 daily dips in the light curve as the binary dwarfs crossed each other every 6 hours. It also saw another slight decline in the observed light every 204 days caused by the eclipsing third star. For now, the stellar threesome has astronomers stumped. Number 1. The entire structure of the universe. Let's start by talking about dark energy, which isn't really related to dark matter. It's just that astronomers call things dark when they don't know what the heck they are. Dark energy is speculated to be the force that is making the universe expand. Maybe it's something like gravity, a force that affects all matter. We just don't know. But many measurements and experiments do confirm that the universe is inflating all the time, and is actually inflating faster and faster. Maps of that light have revealed something truly incomprehensible. Every point in the early universe seems to be pretty much the same temperature, despite each point being casually disconnected from the other.